Hello students. In our previous video, we learned that if line is drawn parallel to one side of a triangle such that it intersects the other two sides, then it will divide the other two sides in equal ratio. That is, the sides will be proportional. And this is called as Basic Proportionality Theorem or BPT. Now students, in our today's video, let us examine that whether converse of Bpt, that is reverse of Basic Proportionality Theorem, is true or not. That is, if we are given that two sides of triangle have same ratio, then will lines be parallel to each other or not? But before proving it, let us perform an activity to understand this. So let's make an angle, say AOB, and mark 5 points C1, C2, C3, C4 and C on arm OA such that segment OC1 is equal to segment C1, C2, which is equal to segment C2, C3 and which is equal to segment C3, C4 equal to segment C4C. Also mark 5 points D1, D2, D3, D4 and D on arm OB such that OD1 is equal to D1, D2 segment, which is equal to D2, D3, which is equal to D3, D4, which is equal to D4, D. Now students, take the ratios of segment OC1 and C1C. Similarly, take the ratio of OD1 and D1D. What do you observe? Yes, both the ratios are equal. Each of them is 1/4. Now students, have you noticed something here? Yes, you are right. Line C1D1 divides both the arms OA and OB in same ratio, that is in equal proportions. Also observe that lines CD and C1D1 are parallel to each other. We can also find the same relationship for all other points on both the arms. Accordingly, if you join C2D2, C3D3, C4D4, we can see that ratio of OC2 to C2C is equal to the ratio of OD2 to the ratio of D to D, which is equal to 2/3. And we can say that line C2D2 is parallel to line CD. Similarly, if we take ratio of OC3 and C3C, it is 3/2. And if we take ratio of OD3 and D3D, it comes out to be 3/2. And therefore, C3D3 line is parallel to line CD. Similarly, the ratio of OC4 and C4C is equal to the ratio of OD4 and D4D, which is nothing but 4/1. And line C4D4 is parallel to line CD. So students, from equations 1, 2, 3 and 4, we find that all lines, whether C1D1 or C2D2 or C3D3 or C4D4, are parallel to line CD. And hence, they are parallel to each other also. Now we can repeat this activity with different angles and different ratios of sides. But every time we will get the same result. That is, each time the ratios of segments will remain same and all lines will be parallel to each other. Now students, observe the figure carefully. Can you identify triangle out of it? Yes. If we consider OCD as one triangle and C1D1 as 2 points on side OC and OD respectively, then line C1D1 divides sides OC and OD in two segments, namely OC1 and C1C on side OC, OD1 and D1D on side OD. We have already seen that ratio of OC1 to C1C and ratio of OD1 to D1D is same. And we have also seen that C1D1 is parallel to CD. Thus we find for a triangle that if line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Now this is converse of basic proportionality theorem, students, isn't it? Yes. So we can write this observation in the form of theorem, which says if a line divides two sides of a triangle in same proportion, then the line is parallel to the third side. Now let's prove this theorem. For that, let's write down given data and what we have to prove. Here we are given a triangle OCD and line EF, which intersects sides OC and OD in points E and F, such that line EF divides sides OC and OD in equal proportion. That is, OE upon EC is equal to OF upon FD. Now we have to prove that line EF is parallel to line CD. To prove this theorem, let's assume that EF is not parallel to CD and draw a line EF dash which is parallel to CD. Now in this condition, according to basic proportionality theorem, we will have OE upon EC equal to OF dash upon F dash D. But students, what we are given? We are given that OE upon EC is equal to OF upon FD. Now this contradicts our equation 1. So by contradiction, we can say that OF dash upon F dash D should be equal to OF upon FD. Now this can be only true if F and F dash points coincide with each other. That is, they are one and the same points. So we can say that F and F dash are same points. So here we can conclude that EF is parallel to CD, since we constructed EF dash to be parallel to CD. So the converse of basic proportionality theorem is also true, which states that if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Students, in our next video, we will learn about angle similarity criteria for two triangles.